All right, let's do this question. Uh, y is equal to this expression, then y is not divisible by which of the following? Okay, so if I were to rewrite this expression, I'll take the denominator and the numerator because it shows -2 as the power of that denominator expression. So it's as good as multiplying 5 to the power 7 minus 5 to the power 4 whole to the power square with this expression in the numerator. So this is our final expression for y. Okay. Now, if we take common elements outside, so from the first term we have 3 to the power 2 as common. So 3 to the power 2 becomes, when you take it outside of the square, it becomes 3 to the power 4. And what we have inside is 3 cube minus 1 whole square. And if you take 5 to the power 4 outside, you have 5 to the power 4, and then you have a power of 2. So this becomes 5 to the power 8. And what remains inside is 5 to the power 3 minus 1 whole square. Now, this is nothing but if I were to rearrange 3 to the power 4 multiplied 5 to the power 8 multiplied 3 to the power 3 minus 1. So 27 minus 1 is 26. 26 to the power 2 multiplied 125 minus 1 is 124 to the power 2. Now, if we rewrite y, so if we look at decomposing 26 and 124 as their prime factors, 26 is 2 into 13. So we will have 2 coming in from there. So 2 squared into 13 squared. And 124 can be factorized as 4 into 31, which is 2 squared into 31, but we have a square over there, so this becomes 31 square and this becomes 2 to the power 4. Okay, multiplied, and then we have 3 to the power 4 and 5 to the power 8 from here, right? Okay, now look at the powers of 2. So this is 2 to the power 2 plus 4, 2 to the power 6. Then we have, let's arrange the prime factors in ascending order. So 3 to the power 4, then we have 5 to the power 8, then we have 13 to the power 2, and then we have 31 to the power 2. Okay, this is our expression of y, and the question asks us y is not divisible by which of the following. The whole idea here is that whatever number we are looking at as divisor, that should be contained in there. All of that should be contained in this expression. Anything which supersedes in terms of powers or in terms of being contained here will not be the correct answer. If you look at, let's go choice by choice. If you look at choice A, 6 to the power 4, do we have that? Yes, we do, because 3 has a power of 4 and 2 also has a power of 4 at least or more, right? So, and 6 is composed of 2 and 3. So therefore, A cannot be our answer, right? So we will cross off choice A because 6 to the power 4 is contained in this expression. So it will exactly divide this expression. What about 62 to the power 2? 62 is composed of 31 and 2, 31 to the into 2 whole to the power 2. So how many? The square means I should have exactly two 31s at least. I should have at least two powers of 31, which we already have, and 2 is already enough in numbers. So this also cannot be our answer. 65 to the power 2 means I need 13 and 5 and at least two powers of those. So 13 and 5, I do have at least two powers of those. So even this cannot be my answer. 15 to the power 4 is 3 into 5 to the power 4. So I need each of 3 and 5s in at least four powers. So we already can see that is there. Okay. And just to validate the last answer choice, 52 is nothing but 52 is 2 square into 13, right? So 52 to the power 4 is nothing but 2 to the power 8, 13 to the power 4. Now, do we have 4 13s here? We don't, right? So this 2 power is the limiting condition for 13. And we don't even have 8 2s also, right? So from either uh, If you look at either of ways, this will be our right answer because this cannot divide our this expression. Thank you.